Hello everyone, in this video we're going to explore topic 7.5, how to use Euler method to approximate a particular solution to a differential equation dy over ds equals f of s and y, right? Because y prime is going to be dy over ds, right? So it could be f of s and y, right? Where y of s0 equals y0, right? It's going to be right here. Alright, now we have the formula yn plus 1, which is the next terms, equals the previous term yn plus h times f of s and yn, right? Where h right here is called the step sign, right? And f of Sn Yn is the derivative evaluated at the current point. Yn plus 1 approximates the value at the next S value. Alright, so let's take a look at the example right here. Example number 1. Use Euler methods to approximate the particular solution of the differential equation y prime equals s times y. Passing through point 0, 1. Use a step size of h equals 0.2. Now question A, approximate y of 0.8. Alright, now first you need to put the initial points over here, right? S equals 0, y equals 1, right? Now this one right here is dy over ds equals s times y, right? Now, in order to calculate this column, you're going to take s times y, it's going to be 0, right? Now, you need to write equation of the tangent line. Remember, you have the point slope form formula y minus y1 equals m times s minus s1, right? Now, m, which is dy over ds right here, right? This is the slope. And s1 y1, which is this guy right here. Alright, so you have equation y minus 1 equals 0 times s minus 0, right? So if you simplify this one, it's going to be y equals 1, right? Now since you have step size s equals 0.2, right? So you're going to keep adding 0.2 to the s column right here each times, right? So it's going to be 0.2, 0.4, 0.6, and 0.8. You're going to stop right here. Why? Because the question asks you to calculate y of 0.8, right? So this is where you stop. Alright. Now, you just got the new value y right here, right? So you put y over here. This could be 1, right? Now m equals dy over ds, which is s times y, so it could be 0.2, right? Now you have y minus y1, which is 1 right here, right? Equals the slope, which is 0.2 right here, times s minus s1, s1 is right here. Alright, now I'm going to simplify this one, so it could be y equals 0.2 minus 0.04 plus 1. So it's going to be y equals 0.2 s plus 0.96, right? Now, in order to calculate the new y values right here, you need to substitute 0.4 for s into this equation right here to solve for y, right? So I'm going to add calculator right here. So I have 0.2 times 0.4, right? Plus 0.96, right? Hit enter. The answer is 1.04. So the value right here should be 1.04. Right? Now dy over ds equals s times y, right? So it's going to be 1.04 times 0.4, right? It's going to be 0.416, right? Alright, so you have y minus y1, which is minus 1.04 equals slope is going to be 0.416 times s minus s1, which means minus 0.4, right? Now I'm going to simplify this one, so it's going to be y equals 0.416 times s minus 0.4 at 1.04, right? So I'm going to substitute 0.6 for s into this equation to solve for y, right? So I'm going to bring up the calculator. So I have 0.416 right here, right? So I'm going to multiply by 0.6 subtract 0.4, which means 0.2, right? And then I'm going to add 1.04, right? And hit enter. The answer is 1.1232, right? So I have new y value is 1.1232. Now I need to calculate the y over the s. So does it mean this guy times this guy, right? So I'm going to multiply by 0.6. The answer is 0.67392, right? So I have new equation y minus y1, which means 1.1232 equals the slope 0.67392 times s minus s1, which means 0.6, right? So I'm going to simplify this one, so y equals 0.6792 times s minus 0.6 at 1.1232, right? So I need to calculate the new y value right here, given s equals 0.8, right? So I'm going to print up the calculator. So whatever I got right here, 0.7392, right? I need to multiply by 0.2, right? Because 0.8 subtract 0.6 is going to be 0.2. And then I'm going to add 1.1232, right? And hit enter. The answer is 1.25798, right? Alright, so you're going to stop right here. This is your answer. Now, question B. Solve the differential equation dy over ds equals s times y with the condition y of 0 equals 1, then find the exact value of. Now, from this equation, I'm going to copy over here. So I have dy over ds equals s times y, right? Now, I need to separate these variables by dividing both sides by y and multiplying both sides by ds, right? So it's going to be dy over y equals s ds, right? Then I'm going to take antiderivative both sides, right? So it's going to be natural log of absolute value of y equals s squared over 2 plus c, right? Now I need to use the initial condition right here to solve for c, right? So s equals 0, y equals 1, right? So this guy turns out to be natural log of absolute value of 1 equals 0 squared over 2 plus c, right? Natural log of 1 equals 0, right? So this guy turns out to be c equals 0. Then the equation becomes natural log of absolute value of y equals s squared over 2 plus 0. I don't need to write, right? Now, since the initial condition right here positive, right? So then I just eliminate the absolute value side. So it will be natural log of y equals s squared over 2, right? Now I need to exponentiate both sides. So this guy turns out to be e raised to this one, e raised to this one, right? So it's going to be y equals e raised to the s squared over 2. This one is the final answer, right? Now, find the exact value of y of 0.8. So I have y of 0.8 equals e raised to the 0.8 squared over 2, right? So I'm going to bring up the calculator. I have e raised to the 0.8 square over 2, right? Hit enter. The answer is 1.37713, right? Now let's move on to question C. The error in using Euler method is the difference between the exact value and the approximate value. What was the error in your answer? Alright, so you have error. So it's going to be exact value is right here. 1.37713. Subtract approximate value which got right here. 1.25798. Right? So I'm going to print up the calculator. So I need to subtract 1.25798. Hit enter. The answer is 0.119148. Now, how could you produce a smaller error using the Euler's method? Alright, in order to produce a smaller error, we need to use smaller step size, right? We need to reduce the smaller step size right here. Alright, the step size is 0.2. We need to reduce this one, right? So, now let's move on to example number 2. Consider the differential equation dy over dx equals s minus y with the condition y of 0 equals 1. Use the Euler's method with 4 equal step size to approximate y of 2, right? So we're gonna scatter the table as we did in the example number 1, right? Alright, you given the initial condition x equals 0, y equals 1, so you're gonna put 0, 1 right here, right? Now you're given 4 equals step size. Then s start from 0 and then end up with 2, right? So the difference between 0 and 2 is going to be 2, right? And then you divide by 4. So you have 2 subtract 0 divided by 4. So you have each step size is going to be 0.5, right? So you're going to add 0.5 each times, right? So the second one should be 0.5. The next one should be 1. The next one should be 1.5. And the last one should be 2 right here. This is what we need to find. It's going to be right here, right? Alright, dy over dx equals s minus y, right? S minus y is going to be negative 1, right? And then the equation of the tangent line is going to be y equals, the slope is right here, negative 1 times s minus s1, which means minus 0, right? Then you're going to add y1, which is 1, right? Remember, you have y minus y1 equals m times s minus s1, right? So I'm going to add y1 both sides, so it will be y equals m times s minus s1 plus y1. That's why I get this one right here, right? Now, I need to evaluate y of 0.5 to find the value right here, right? I substitute 0.5 for s into this equation, right? So does that mean I have y equals negative 1 times 0.5 minus 0 is going to be 0.5, right? Plus 1. So it's going to be negative 0.5 plus 1 is going to be 0.5, right? So I have 0.5 right here, right? Now dy over dx equals s minus y, so it's going to be 0 right here, right? So the equation becomes y equals, the slope equals 0 multiplied by this one is going to be 0, right? So I just add y1 both sides. y1 equals 0.5 right here, right? So it could be 0.5, right? Now I put 0.5 right here, right? No matter what values of s is, y is still the same, right? So s minus y is going to be 0.5 here, right? Then I have y equals, the slope is going to be 0.5 times s minus 1, right? At 0.5, right? So I substitute 1.5 for s into this equation. So I have y equals 0.5 times 1.5 minus 1 plus 0.5, right? 1.5 minus 1 is going to be 0.5. 0.5 times 0.5 is going to be 0.25 plus 0.5 is going to be 0.75, right? So I have 0.75 right here. Now dy over ds equals s minus y, so it's going to be 0.75, right? Alright, now I have the equation y equals, the slope is going to be 0.75 times s minus 1.5 plus y1, which means 0.75, right? So I substitute 2 for s into this one to solve for y, right? So I have y equals 0.75 times 2 minus 1.5, right? Plus 0.75, right? So I have 0.75 times 2 minus 1.5, which means 0.5, right? Plus 0.75. Hit enter. The answer is 1.125. And this one is the final answer. Now let's move on to example number 3. This one comes from AP Calculus BC 2021. Free response question 5b. Let y equals fs be the particular solution to the differential equation dy over ds equals y times s natural log of s with the initial condition y of 1 equals 4. It can be shown that the second derivative of f of 1 equals 4. Now, use the Euler method starting from s equals 1 with 2 steps of equal sign to approximate f of 2. You're going to do exactly the same thing, right? You're going to sketch the table. Now, initial condition is right here, 1 and 4, right? So s equals 1, y equals 4, right? Now, 2 step size of equal sign, right? The final value should be 2, right? So this guy should be 1.5 and the last one should be 2, right? Why? Because the step size h equals 2, the final values, subtract the initial value, which means 1, right? Divide by 2 step size right here, right? So it could be 0.5, right? So you need to add 0.5 8 times, right? So it could be right here. Now, dy over ds, which is right here. Alright, so you have y times s times natural log of s, right? Natural log of 1 equals 0, right? 0 times s, it could be 0 times y is still 0, right? Now the equation should be y equals 0 times s minus 1 and 4. It's going to be 4, right? Now, no matter what value of s is, y is still 4, so I just put 4 right here, right? Same thing, I need to calculate dy over ds, right? So it could be y times s times natural log of s, right? So I have, now y times s, it could be 4 times 1.5, it could be 6, right? So it could be 6 natural log of 1.5, right? So the equation should be y equals 6 times natural log of 1.5 times s minus 1.5, right? Plus y, which is 4, right? Now I substitute 2 for s into this equation to solve for y, and this is my final answer, right? So it's going to be y equals 6 times natural log of 1.5 times 2 subtract 1.5, which means 0.5, right? Plus 4, right? So I'm going to bring up the calculator. So I have 6 times 0.5, right? Times natural log of 1.5. Then I'm going to add 4. Hit enter. The answer is 5.2164. 5.2164, 4. This one is the final answer. Now let's move on to question C. Find the particular solution y equals fs to the differential equation dy over ds equals y times s natural log of s with the initial condition f of 1 equals 4, right? So from this equation right here, I need to separate this variable, right? So you need to divide both sides by y and multiply both sides by ds. So it turns out to be dy over y equals s natural log of s ds, right? Then you need to take antiderivative both sides, right? So it can be natural log of absolute value of y equals. In order to calculate antiderivative of the right hand side, we need to use integration by parts, right? So remember we have L, I, A, T, E, right? Now L stands for natural log, right? So we have log right here. We need to let this one be U, right? So we let U equals natural log of S, then du equals 1 over S ds, right? Now dv equals the remaining one, which is S times ds, right? Then we have v equals S squared over 2, right? So we have antiderivative of S natural log of S ds equals U times v, which is S squared over 2 times natural log of S minus antiderivative of v du, which is S squared over 2 times 1 over S ds, right? So this guy turns out to be 1/2 S squared natural log of S, right? Minus antiderivative of 1/2, I'm going to put in the front, right? So it's going to be S ds, right? So this guy turns out to be 1/2 S squared natural log of S minus 1/2 S squared over 2 plus C, right? So it could be 1/2 S squared natural log of S minus 1 over 4 S squared plus C, right? So I'm going to bring this one over here. We need to use initial condition right here to solve for C, right? So we have natural log of 4 equals 1/2 1 squared times natural log of 1 minus 1 over 4 times 1 squared plus C, right? So C equals, this one equals 0, right? Natural log of 4 plus 1 over 4, right? So the equation becomes natural log of absolute value of y equals 1/2 S squared natural log of S minus 1 over 4 S squared plus 1 over 4 plus natural log of 4, right? Now I need to solve for y, so I need to exponentiate both sides, right? So have e raised to this one equals e raised to the whole thing right here, right? So you have absolute value of y equals e raised to this one, right? Now since the initial condition is positive, right? So I can eliminate the absolute value side right here. One is the answer. Remember, the domain for this equation is s greater than 0 because you have natural log of s right here is defined when s greater than 0. Alright, so keep that in mind. Now, example number 4, AP Calculus BC 27, free response question number 5. Consider the differential equation dy over ds equals 3s plus 2y plus 1. Question A. Find the second derivative of this one, right? So, we have d squared y over ds squared equals. Now, we need to calculate derivative of this one with respect to s, right? So it could be 3, right? This guy turns out to be 2 dy over ds, right? This one is a constant, so it's going to be 0, right? Now, it's going to be 3 plus 2 times dy over ds equals the whole thing right here. So it could be 3s plus 2y plus 1, right? Now I need to distribute this one and I'm going to simplify it, right? So it turns out to be 6s plus 4y plus 5. This one is the final answer. Now question B. Find the values of the constant m, b, and r for which y equals ms plus b plus e raised to the rs is a solution to the differential equation. Alright, we have the differential equation is right here, right? So this one is the solution of this one. You're gonna check the derivative of this one first because we have dy over ds right here. Look, alright. So right here it turns out to be dy over ds equals, right? Take the derivative of this one with respect to s, so it will be m, right? Derivative of b equals 0, right? Derivative of e raised to the a s plus b is going to be a times e raised to the a s plus b, right? Remember you have e raised to the u, right? It's going to be u prime times e raised to the u. It's going to be like right here, right? So this guy turns out to be r times e raised to the rs, right? Now I substitute m plus this one right here for dy over ds back to this equation right here. So I have m plus r times e raised to the rs equals 3s plus 2y, but y equal this one right here, right? So I have ms plus b plus e raised to the rs plus 1, right? Now I need to distribute this one and I'm gonna group them, right? So I have m plus r times e raised to the rs equals 3s plus 2ms plus 2b plus 2e raised to the rs plus 1. Now I need to group this one, so this guy turns out to be m plus r times e raised to the rs equals, look at this one right here, m is a constant, right? So the constant right here 2b plus 1, so I have 2b plus 1, right? Now next one, r times e to the rs, so it will be right here 2 times e raised to the rs, right? Now the last one right here, I need to factor s out, so it will be 3 plus 2m times s, right? Now look at the left side right here, I don't have s, so I put s right here, plus 0 times s, right? So I just equate the coefficient both sides to get a system of equations, right? Now this guy right here and this guy right here must be the same, so I have m equals 2b plus 1. Now the second one, r right here and 2 right here must be the same, right? So r equals 2. Now the last one, 0 right here and 3 plus 2m right here must be the same, right? So I have 3 plus 2m equals 0, right? Now from the third equation right here, I can solve for m, so m equals negative 3.5, right? I substitute back over here to solve for b, right? So I have 2b equals negative 1 plus negative 3.5 is going to be negative 5.5, right? So b equals negative 5 over 4, right? Now this one is the first case. Now the second case, what if r equals 0? Then I have the left hand side becomes m plus 0 times e raised to the 0 s plus 0 s equals the right hand side is going to be 2b plus 1 plus 2 times e raised to the 0s, right? Plus 3 plus 2m times s, right? Now the right hand side right here, observe that this one is a constant, right? So it could be 2. I'm going to add over here. So this guy turns out to be 2b plus 3, right? Plus 3 plus 2m times s, right? Now the left hand side becomes m plus 0s, right? So I have a system of equation 2b plus 3 equals m, right? And 3 plus 2m equals 0, right? I need to solve for m and b, right? I substitute 2b plus 3 for m into the second equation. So I have 3 plus 2 times 2b plus 3 equals 0, right? So it turns out to be 4b equals -9, right? So b equals -9/4. Now I'm going to use the second equation right here to solve for m. So m equals -3/2. Right? And r equals 0, right? So the second case, r equals 0, m equals -3/2, and b equals -9/4. The first case, you have r equals 2, m equals -3/2, and b equals -5/4. Now let's move on to question C. Let y equals f of s be a particular solution to the differential equation with the initial condition f of 0 equals -2. Use Euler's method solving s equals 0 with a step size of 1/2 to approximate f of 1. Right? So you're going to sketch the table, right? So you have s right here, y right here, dy over ds, right? And this one is the equation of the tangent line, right? Now the initial condition is going to be 0 and -2, right? So s equals 0, y equals -2, right? The step side right here, h equals 0.5, right? And the final value is 1 right here, right? So you keep adding 0.5 until you get 1, right? So it could be 0.5 right here, right? Because 0 adds 0.5 is going to be 0.5. 0.5 adds 0.5 is going to be 1. We stop right here, right? Because we need to calculate this one right here. Alright, now I need to substitute 0 for s and -2 for y into this equation right here to solve for dy over ds, right? So this guy turns out to be -3, right? And the equation should be y equals, the slope is -3 times s minus s1 plus y1, which means -2, right? I need to substitute 0.5 for s into this equation to solve for new y, right? So it's going to be y equals -3 times 0.5, subtract 0 is going to be 0.5 minus 2, right? So -3 times 0.5 is going to be -1.5, subtract 2 is going to be -3.5, right? So it will be -3.5 right here. Alright, now dy over ds equals 3 times s, it could be 1.5, right? 2y, which means -7, right? Plus 1. It's going to be -4.5, right? Now y equals -4.5 times s minus 0.5, right? Minus 3.5, right? I substitute 1 for s, so it's going to be y equals -4.5 times 1 subtract 0.5 is going to be 0.5 subtract 3.5, right? So you have -0.5 times 0.5 subtract 3.5. Enter. The answer is negative 5.75. This one is the final answer. Now let's move on to question D. Let y equals g of s be another solution to the differential equation with the initial condition g of 0 equals k, where k is a constant. Euler's method starting from s equals 0 with a step size of 1 gives the approximation g of 1 equals 0. Find the value of k. Alright, so this problem we're gonna do backwards, right? We need to find initial condition right here, right? So we just get a table, right? Now, s equals 0, y equals k, right? So we have 0, k here, right? Now, the step size is 1, right? And the final value should be 1, right? So I have 1 right here. dy over ds equals 3s plus 2y plus 1. So it could be 2k plus 1, right? Equation of the tangent line should be y equals the slope is to be 2k plus 1 times s minus s1. s1 equals 0, right? Plus y1 should be k, right? Now I change this one into g so that I'm going to use this one easily right here, right? Now substitute 1 for s into this equation. Does that mean I get g of 1, right? It's going to be 2k plus 1 times 1 minus 0 plus k, and this one equals 0 right here, right? Now I need to solve for k, right? So 1 minus 0 equals 1, right? So I have 2k plus k, it's going to be 3k plus 1 equals 0. K equals negative 1 over 3. This one is the final answer. Now let's move on to the last example. Example number 5 is similar to example number 1. I'm going to leave this one for you to practice. I just give you the answer key. And it's your time to start. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young, it has just begun as she puts her hand in mine.